Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, California Resources Corporation, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, Bakersfield City School District, and the Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Devin. Hey, thank you so much for joining us this afternoon. It's a wild Wednesday. We've got a lot of ground to cover, and we need you to join us on this ride. If you're in Bakersfield, give us a call at 636-4357. The San Luis Obispo area, call us toll free at 1-866-636-6284. You can always email us with those questions that you'd love us to help you out with at dothemath@kern.org. You can watch us online at dothemathonline.net and look out for us on social media, on Facebook, on Instagram, on Twitter. Watch us on YouTube, post those comments, let us know how we can help you. Join us in our conversation here today.
On Diner, on Blitz, and on when you
do
were
it.
going
I'm
there, I was
ready.
like, we're going on a roll there.
I can breathe now.
All right. Hey, listen, we do have phone tutors until 5:30, as Devin had mentioned, most Tuesdays and Wednesdays throughout the regular school year. And we'll be going out and about with Marylou in a little bit. And we have a special guest in studio. The race between the two schools in San Luis Obispo County is tightening up. And that is a very important contest because two schools have gone after each other, let's say, and they're going against each other to see which school can call in the most between September and early December. So there's the information. The winning school will win themselves a behind-the-scenes tour of Doc Bernstein's Ice Cream Lab and the major ice cream making facility.
Get after it, kids.
Do you have a favorite flavor?
Usually go with Rocky Road, but mint chocolate chip always has a place.
Always good.
Express Lane.
Have you been to Doc Bernstein's Ice Cream?
Actually, yeah, a few years ago, got a chance to visit there with my wife and daughter.
Lovely item called motor oil.
Tell us about motor oil.
You know what? Motor oil is chocolate with a fudge in there, and so it's just outstanding ice cream. Anyway, before we get to our first phone call of the day and our special guest, let's first take a look at today's Math in the News. Now, this event is actually coming up tomorrow. But since we don't air live on a Thursday, I figured we would go ahead and do it today. October 11th is World Sight Day.
Happy World Sight Day, everybody. Phenomenal.
It's an international day of awareness held annually on the second Thursday of October to focus attention on the global issue of avoidable blindness and visual impairment. Now, many years ago, I volunteered for there's a place in Bakersfield for the visually impaired.
Okay.
And I think this is something that you can do also. You find a little bit of time in your day. Like we have a lot of it, right?
I see.
But anyway, I see. You can record books on tape for the folks that are there.
Oh, wonderful.
And a lot of these things are, I mean, they're not novels and things because they have a lot of the famous Hollywood actors doing those things already.
Right.
But manuals that they need to read, things like that.
Okay.
Manuals,
instructions,
things, right. So
right.
Basic things like that. So that's what made me think about this is this World Eye Day coming up, World Sight Day. So have you ever imagined your eyeball like out and like you could hold it and look at your eyeball, like you could examine it?
It's very trusting. I feel like that would be somewhat of an out-of-body experience, one that I've actually had a doctor do on my vision when I had my laser surgery. They somewhat went
so
in
you've
on
had that done?
Yeah.
And how long ago did you have that done?
This will be about a year ago now.
Okay.
Yeah.
And everything's been well? I mean,
phenomenal.
No complications
Real
or anything
clear.
with that?
Yeah, absolutely.
Now that's where they put a cut in the cornea, right? Slice it.
Yeah. Well, some of them do. They can cut around, peel it back, and then zap in, or some of them take it right off and then do the same thing.
That's what I'm talking about.
Very
Imagine
graphic.
that, just that gelatinous substance, feel, texture of it.
Stay with us, everybody. It's
Anyway, so here's a normal eye anatomy. We can see many of the various parts right here, and then an actual eyeball right there. So I was like, all right, let's get a little bit into this, see what we can do as far as mathematics is concerned with this.
Let's dive in.
So we can see, were you nearsighted or farsighted?
I was very nearsighted.
Okay. So for those of you that aren't familiar with that, nearsighted means you're able to see things up close. You're unable to see things far away.
Beyond this distance here, beyond this, everything would be blurry.
Right.
Yeah.
Which I am as well, which is why I've got the eyeballs and the eyewear. All right. So I'm like, all right, this is all cool. You can see how the light is brought into the eye and how the differences are between normal vision, farsighted, nearsighted, and things. So now we get into the math of this. So when you receive a prescription for eyeglasses, contacts, whatever it is, you can see a lot of the numbers up there, and we'll leave it up for a moment so some of the kids at home can take a look at that if they seem interested in what the numbers stand for. But what do you notice about the numbers?
Well, they all seem to deal with positive or negative integers.
Right, so they've got positives and negatives, right? So, I mean, there aren't any negative symbols on here, but they deal a lot with positives and negatives, and we can see right here that they're talking about the positives and negatives with the numbers as far as the prescription is concerned. So now we tie that into math with the ever wonderful integers that kids seem to have a little problem with when they're dealing with positives and negatives. So 5 plus 2 is 7. Most students can look at that and after first grade not have a problem with that at all. But when it comes to negative 10 plus 12, for some reason, having the negative number first throws people off. Now, negative 10 plus 12 would be the same thing as 12 minus 10. So to be able to think and see that, and the same thing with an 8 plus a negative 10, and there are just some examples right here, and I figured we would put that up just as an example of the integers and how students are getting used to them and how they are applied in prescriptions, and all because of World Sight Day.
So you could do a comparison, let's say. If I was nearsighted, you were farsighted, we
Take a
could
look at
talk
the-
about how much different our visual perception really could be.
Right, take a look at the prescriptions and see what there is, the differences in those, and find out the difference between the two different prescriptions.
Right.
And that is today's Math in the News. 636-4357 is the phone number. We do have phone tutors available until 5:30. In studio with us, our special guest of the day, Emily. How are you?
Good, how are you?
I'm excellent myself. Why don't you let everybody know where you go to school and what grade you're in?
I'm in 4th grade. I go to Stockdale Elementary School.
And have you been at Stockdale for a long time?
I've been there since kindergarten.
Since
so-
kindergarten, all right, so you've been there quite a while. So you're in 4th grade now, and that's a little bit of a change, isn't it? Mm-hmm. From 3rd grade. What's the biggest thing that you notice between 3rd and 4th grade?
The subjects get a lot harder.
The subjects get a lot harder, huh?
Class, yeah.
Is there anything that is more difficult than something else?
The math has gotten a lot harder.
The math has gotten a lot harder? Well, you know what? It's a good thing you're here today, so we can help you out with some of that. Have you dealt with positive and negative numbers, integers like that?
Yeah,
A little bit?
a little bit.
All right, good. Let's have you do some more. Over to the board, young lady.
Come on over.
Here we go. All right, so Devin, why don't you go ahead and write up this string of numbers, and Emily, you're going to help me decide on some of the numbers, all right? So Emily, pick a single-digit number between 1 and 9, any one of those numbers.
Let me know so I can write it down. Yeah. She said 7. All right, I'll put a 7
All
right there.
So put a comma after that,
Okay.
and let's go -4, and you write it down, Emily, however you like. Okay, after that, put a comma. Emily, choose another number, positive or negative, single digit. -3. Devin, let's go with a +8.
Positive 8.
So you need to write that one up there also, Emily. It's +8. So you guys are going to write down the same numbers. And let's go one more. Let's go -5. So add a -5 to your lists. And Emily, what I'd like you to do is I would like you to take all of those numbers add them up, combine them, and tell me what the final answer is. So you're going to add all of those numbers together. So you can rewrite them in a different way if you'd like to, but as you're doing it, explain it to Devin so that he understands what you're doing and can help you out if you need it.
Usually to make an equation easier, I'll, if it's negative and positive numbers, I'll change all the numbers to positive or negative, whether there's more positive or negative numbers. And here there's more negative numbers, so I'm going to change all the numbers to a negative number.
Okay, so you actually want to start with them as one sign first, okay? So let's do that. I want to see, go ahead and I want to see you work out your strategy on this. So you're going to convert all of these values to negatives, okay?
Yeah.
So you have now 7 turns into -7. We're going to keep 4 negative. We're going to keep 3 negative. We're going to keep 8 negative. Now we're going to move that over as a negative value. And now we're going to keep -5 negative. Okay, so you have converted all of these values to negatives. So how do you think that helps you add all these together?
It helps me add all the numbers together because when you understand how to do a negative equation, it's like doing a positive addition equation. So it's easier to add all the numbers up together to get the answer.
Okay. Let me see if we can maybe think about positives and negatives differently. When we think of positives and negatives, we like to think of those as opposites, right?
Yeah.
So when we have a positive and a negative, sometimes it's very helpful to think of equal parts of those kind of canceling each other out. So for example, if I had +2 and I combine that with -2, I'm going to end up with 0. I'm going to end up with nothing, right? Let's say like I give you $2 and then you owe me $2. How much money do you end up with at the very end?
No money.
Nothing,
at all.
right? So that's what we want to think about in the relationship with positives and negatives. So here's what I'd like you to consider. What if instead of turning all of the values, I can go ahead and just jump these out of the way. What if instead of turning all values positive or all values negative, we combine the values of all the positives, 7 and 8, and we combined all of the values of all of our negatives, 4, 3, and 5, and then did a comparison of those sets. Want to try that?
Yeah.
So which one would you like to work with, the positives or the negatives?
Usually positives are
Go
a
ahead
lot
and
easier.
add all those positives together, right? So you're going to have 7 plus 8.
Might need to move this. Is it okay if I move this a little?
Yeah, absolutely. We can throw these anywhere we want. They start bouncing too if you get a lot of force behind them. So 7 plus 8 is 15. I mean, very straightforward. Now, we can add the value of all of our negatives together too. Ignoring the negatives, but we'll come back to them, right? I don't want to just ignore them or toss them away, but I want to think about what happens when we add 4 and 3 and 5. And we can add these in any order, right? So I could say 4 plus 3 is 7, and then 7 plus 5 is 12. So if I combine these together, I have negative 12. Now let's take a look at negative 12 and positive 15. If there's enough in this 15, I can actually cancel out some of this negative 12 here, right? So let's maybe think about this 15, all right? Let's think about this 15. How could we break up this 15 into 2 chunks so that one of the chunks can cancel out our negative 12?
You can split them by 12 and 3.
Let's do that, 12 and 3, okay? So we have a 12 and we have a 3. Let's take this 12. Am I going to be able to move it over? Let's bring this negative 12 here, and we're going to cancel it out. Boom, 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 they have a fight, and now the 12s cancel out. Positive and negative, that ends up being 0 now, right? This zero's away. What's left?
3.
So when we combine all of these positives and all of these negatives together, we end up with 3 as our sum. So it's a little bit of a different way to think about numbers. We don't usually think about numbers being able to cancel each other out, but that's exactly what we can do with positives and negatives because opposites collide. So that's something that when we get into more issues of negatives and positives, when we explore integers, we don't really think of it as a total quantity because we think of it as a number line. And we can explore that further down the line, but it's really interesting to think about positive values that we can use to break down and cancel out negatives because we can do the same thing if we have more negatives than positives.
All right, nicely done, guys. So that's your first one with that. We'll do a little bit more on that in a little bit from now. Anyway, we do have phone tutors available until 5:30 this afternoon. We have a few phone callers to get to, but first we're going to go out and about with Marylou.
Do you ever wonder how speed limits are determined on a street or where signals are placed? Well, today we are at the Public Works Traffic Division and I'm with Ed Murphy, Civil Engineer 3. How
Hello.
are you doing?
Doing wonderful.
Can
Welcome.
you quickly tell everybody exactly what it is that you do here?
We are in charge of pretty much all things traffic in the city. We have 2 divisions, one's in planning and development, and one's in operations. I'm in charge of operations, that's handling signal timing, striping on the roadways, everything that the cars are using while they're out there, cars, vehicles, bicycles and pedestrians out there on the roadway. And then there's the planning division, which develops future streets and future projects and things like that. So
Can you tell us where we are right now?
we are right now in our office here at City Hall in the Public Works Traffic Division. There's 8 of us on staff here, about half of us for operations, half of us for planning. And this is where all the magic happens as far as trying to keep traffic flowing efficiently and well throughout the city of Bakersfield.
Now, there's another room here in your office
There
that
is.
is really interesting.
It is.
And can you take us to that?
I would love to. It's called
Okay.
our Traffic Operations Center.
Okay.
Let's head back there now.
And what exactly is going on here in this room?
Well, the Traffic Operations Center is, we have programs in the computers that are connected to all of the city signals. Well, I shouldn't say all of them, but at least we have about 420 signals, and at least like 380 are connected through the city, through conduit that we've been placing in the roadways on construction projects for the past 20 plus years. Anytime there's construction going on, we would lay this in the ground, and then we pull fiber or copper wire through and have it bring all those signals here to this brainchild, if you will, the Traffic Operations Center. And this is a map that shows all the signals that are connected to the city. Each one of these little dots is a signal light out there in the city, and if it's green, that means we have good communication from here all the way out to the signal light, wherever it is, out in the outskirts or even close to downtown here. You can see all the signals that are really congested right down here
Now,
in downtown.
we were talking earlier about the different colors, and I was talking about getting here. I had to travel down Rosedale Highway.
Right.
So I was kind of wondering, hey, am I being detected on Rosedale Highway? What lights am I going through? And then you were pointing out the white. What does that mean with the white?
The white, we don't have communication with it at all. The red shows that we have communication with the signal, but it means we've lost communication with the signal. That's not necessarily a bad thing. For example, here near the freeway, this is 99. These are Caltrans state signals, so although we have connection with it, we're not in control of it. That's why those stay red all the time. But other places, such as this on, I believe that's Ming Avenue, there may be something wrong with that signal out at Ming. If there is blue, that's another alarm that something's wrong with it, but the red means that we've lost communication. That could be a construction project that's going on. Not necessarily always a bad thing, but at least it warns us to let us know we don't have communication. If an emergency vehicle comes through, these lights turn pink. It shows that they're being preempted. You know, a fire truck or an ambulance or police, you know, needs to get through and clear the intersection they have a little strobe light on top of their car that triggers this little thing that's on top of the signal light. And it reads it and it knows that an emergency vehicle needs to get through. And it turns the signal green so that they can make it through the intersection. Obviously, when someone's life is in danger, we want to get the emergency first responders there as fast as we can.
So you don't
and this
have
helps us do that.
the cross traffic.
You don't have to sit there waiting for
Yeah.
the light to change. It preempts it, it turns it green so that the intersection can clear and hopefully prevent a
Over
disaster.
here, we got
Yes.
cameras going on.
Yes, these are connected to these. The cameras, we have about 30 cameras, not at every location, obviously. We have way more signals. We're adding more as time goes on. That's great. Here's an example of, we could see what's going on out there. We're not recording anything, but if there's something, a triggered light, let's say it goes red or something, we can pull up a camera if we have that in the location and see maybe there was a collision out there that took out the box, or there was something else that's happening for a flood or something, or maybe it looks like nothing happens and maybe that triggers that something's wrong with the wiring and the signal itself. But this gives us an idea of what's going on, behavior at the intersection. Here's something also that's reflecting the same intersection, Stockdale Highway and California Avenue. And these are both in real time. You could see the eastbound through and the eastbound left turn lanes, it has a green light right now. So as you saw them, they were turning left and going through still. Now it turned yellow, and one of the other directions is going to turn green. Right here, the through south and the through left, and there they go.
There they go.
And then they're making the left turn. So
Now,
that's all
you
good.
even can see pedestrians, right?
There are. Here's a pedestrian right here. They hit the button, the pedestrian button. Unfortunately, we can't see them on the deal there. And they're wanting to cross this way, it looks like. So the signal knows when you press that pedestrian button, there's a pedestrian here, and it usually gives a little more time for a typical walking pace for somebody to make it across the signal, or to make it across the intersection. And Stein Road and it's a big intersection. It's not like a local road where you live in your neighborhood. It's wider. Typically about 90 feet or 110 feet usually about there.
Well, there's
So-
a lot of math required with this, right?
is.
So when we come back, we're going to kind of go over how you determine speed limits, correct?
We will see, how we can determine the speed of a car,
Awesome. Okay. And we will be back in a little bit.
All right, thanks for that. A lot of behind the scenes information right there, and a lot of people wonder, well, how does that stuff work? Well, that's exactly what we're doing when we send Marylou, Devin, Scott, and some of the other tutors out and about throughout Bakersfield and Kern County. Hey, we do have phone tutors available until 5:30. We've got Emily in studio, but right now we're going to go to the phones. Caitlin, how are you this afternoon?
Good.
You are a 6th grade student, correct?
Yes.
And you've called in quite a few times, and I believe you're working on an equation today, correct?
Yes.
All right, let's hear what it is.
So it's 6, open parentheses, x plus 2, close parentheses, minus 4x equals 48.
Equals 48. So we're looking to find for x here. So we've got a few elements that we're really looking at here. We've got distributive property, it looks like, with a coefficient next to parentheses. And then we also have a variable that we're going to subtract from that. So which of these would you like to tackle first as far as simplifying this expression so that we can find what x equals?
So I first did, I did the distributive property, so I did 6 times x,
Okay.
and I got 6x,
So what about the other part of that parentheses? What would we do with
and
that?
then I did 6 times 2, and I got 12.
Okay, so are we going to add 12 to that, subtract 12?
You're going to add,
Okay, so we have 6x plus 12 minus 4x equals 48. Okay.
yes. And then I moved the positive 12 to the other side of the equal sign, and it became negative 12.
So we are going to take 12 away from both sides. Whatever we do to one side of an equation, we do to the other. So that's going to remove that constant from here and give us 48 minus 12 on the other side. So what does that equal, Caitlin? Here's a hint. It's on the board. 48 minus 12, so that gives us 36 on our other side. So now we have, I believe, 6x minus 4x to equal 36. What can we do with that?
Are you still there, Caitlin? Okay, it sounds like we may have had the phone call
Ooh.
drop because there's no response from Caitlin, and she's a repeat caller, so I know she's usually there.
Get back to us, Caitlin.
So-
We're almost there.
Devin, how about you go ahead and keep going with the problem, and that way if Caitlin is viewing the program, she can still watch it, whatever happened with the phone, but we'll go ahead and finish the problem right now.
Well, the good news is that we're real close to the end here. So we have 6x minus 4x. We can take 4x away from 6x. That leaves us with 2x. So we know that 2x is going to be equal to 36. In order to get that x by itself, we want to make sure that we can divide it by 2. But whatever we do to the left side of the equation, we do to the right side. Let's divide both sides by 2. So we end up with x equaling 36 divided by 2, which would be 18. X would equal 18 in that original equation, Caitlin, and I hope you do get a chance to see that. Thank you for working with us.
And you probably did right
thank
there, and I
you.
think the applause was that you finished it on time.
I mean, I did put
Hey,
the effort in.
Nicely done. Anyway, Caitlin, congratulations for calling in with that problem. We're going to send you a gift card courtesy of our friends at Chick-fil-A. Not a bad deal, huh?
Great. That's
all right.
That's fun.
Emily, you nice and relaxed?
Yeah.
That was pretty good to watch that, huh? All right, now we're going to watch you do some work. Get over to the board. All right, we're going to take a look at your problem. This is out of your homework packet, and it looks like you're working on multiplication right now and expanded form. So it says multiply 5 times 143, and they want that in expanded form. So they want the 143 in expanded form is the first thing they want.
So let's think about how we can expand this expression here. And the distributive property is going to be represented here, but you know, what can we really expand? Can we expand the 5? No, we can expand maybe 143. How can we break that down into expanded form?
We can break it into 100, to 40, and to 3.
So thinking back to the last problem we did with Caitlin, we could write this then in an expanded version like this. So we have 5 times, and let's put this in parentheses, 143, or 100 plus 40 plus 3. Now, is there a way for us to represent this using the distributive property? Because if you remember, anything that's outside of parentheses, we can multiply it into everything inside of parentheses. So what would that look like here? If we multiply these terms, how can we write that?
So let's go ahead and look at the book because I think they've already got one of these done for you. So the first one we've got is 5 times 100. And then we need 2 more sets like that.
So we did 5 times 100. Now we can move to the next term in this parentheses, which is
5 times 40.
5 times 40. Go ahead and put that parenthesis next to our set here. So I'll do it right there. Start that off for you. And then we have one more term we can distribute.
5
Into the
times
3. So what would that look like?
5 times 3.
Let's go ahead and do 5 times 3 over there as well. So how familiar are you with looking at the area model when we multiply? Have you seen the area model before?
Yeah, we did a little bit of it in 3rd grade.
A little bit of it in 3rd grade. And the idea behind the area model is that you can look at multiplying 2 values as if you were finding the area of a rectangle. So 5 times 143 can also be represented by a rectangle that is 5 tall and 143 long. This is a really skinny, super long rectangle. But if you think about how we broke this up, we don't have to say this whole thing is 143. We can say this is a rectangle that is 100 plus 40 plus 3. Now, if you remember finding the area of rectangles, we would find the area by multiplying the length times the width. So we can kind of see that in place here with super easy numbers. So instead of multiplying 143, let's multiply 5 times 100. What does 5 times 100 equal?
500.
500. Go ahead and write that in that rectangle here. Now, which of these other two would you like to do next? 5 times 40 or 5 times 3?
5 times 40.
Let's do 5 times 40. What would that equal?
200.
Let's go ahead and put 200 in that. And we have 1 left here.
5 times 3, which would be 15.
So we have 15. Now, we know that the area of this rectangle is 500. The area of this rectangle is 200. The area of this rectangle is 15. What would the area of the whole rectangle equal? Go ahead.
715.
So how did you do that? You added all 3 of these together?
Yeah.
So 715. So what we're saying here is that 5 times 143 equals 715. What a way to multiply, Emily.
Nicely done. And 715. Now, I don't think Emily is going to know the significance of that number, but Devin, I'm going to see because you are of the appropriate age and a sports.
Oh, don't do this to me.
So
Mike.
why is 715 an important number?
Oh, that used to be the old home run record held
That's
by
right.
Hank Aaron.
That's right. So 714 was the number a long time for Babe Ruth. Hank Aaron broke it with 715, and since then, many other things have happened with baseball, but that's a big number still in baseball, and a little something for you there, Noof, right? So anyway, we'll be out checking out what's going on with Marylou in a little bit. We'll get to another phone call, and we'll do all of that right after this. Today we're at Piute Mountain School, home of the Wranglers, and we're here to we're back at Piute Mountain School, and we have the 6th, 7th, and 8th graders all working on some multiplying and then filling in a grid to see if they can come up with a strategy where they can get exactly 100, and if not, how close they can get to that 100 right there. Oh, time's up. Look at that. Perfect right there. All right, you know what? Let's go around. Keep on working, though, even though the bell went off. You can keep working until I come to you. All right? So let's take a look and see what... So you guys started off with a 6x6 to 36. Do you remember how you shaded in first?
I just put it on.
So you just went all the way across starting from the top. So you went from the top working down,
Yes.
right? And you've got your 10 rolls. And how many spaces do you have left?
I have 4.
All right, so you have 4 left. So that's pretty good, right? Did anybody else here get, you got 4 exactly?
I got 3.
You got 3. 15 out of the 10 rolls? All right, so you can see it's just a chance on what numbers you're going to get. All right, and out of the 10 rolls, so far we've got 3 as the one that is in the lead so far, right? All right, let's go over here. We'll find out what these guys have been doing. All right, so you got 4 rolls, and it looks like you're about halfway through. So you're on your way to possibly filling this whole thing in. And how many do you have left? You have 4 rolls left? And how many squares do you have left?
2.
So if you need 2 squares, but you've got 4 rolls, do you think you can get a 2 exactly? How are you going to be able to get a 2? What's the only way you can get a 2 with your dice? A 1 and a 2, right? So let's go ahead and roll them. Let's see if it happens within 4 rolls. Oh, a 2 and a 2. So write down 2 and 2, but you can't fill it in because you have more than that. All right, so let's see. You think it's going to happen? All right. You're on your last roll, huh? 5 and 3. Oh,
I can't roll.
too many. All right. So you're just going to do 3 more rolls in a row. 2 by 5. 4 by 3. Coming down to the last roll. Let's see if she can do it. A 1 and a 2, a 1 and a 2, a 1 and a 2. Oh, check that out. On the final roll, she got a 1 and a 2, exactly what she needed to fill it in. got exactly 100. Nicely done on that final roll, a 1 and a 2. You've got a couple of rolls left. All right, 2 rolls left and 2 rolls. All right, let's go, girls. See if you can get it all filled in. 1 and a 6, that'll help out. Another 6 with a 2 and a 3. Oh, you need the same thing. You need 2. Only 1 roll, though. Oh, you know what? Here, I'm going to let you do that one again because it hit her hand. Maybe that deflected it. We'll go ahead and do that again. Oh! Somebody, we got to do something else because a 1 and a 2 on your last roll, you got it. You got a 1 and a 2 on your last roll. The luck is in the room today at Piute Mountain School. All right. 6th graders are doing well. We've already gotten the 8th graders correct, and we've got somebody with 3. And we have 2 girls over there that got 1 and a 2 on the last roll. Amazing. How did you guys do? Did you get exactly 100? Yes. On 10 rolls? And you ended up, oh, with a 1 and a 1. That's pretty close. You have 2 rolls left, but you're already full. Yes. And you got 100 in less than 10 rolls. Yes. Even better. And you got 100 in how many rolls did you have left? You had 3 rolls and he had 2. So you know what? I think you did it the fastest, obviously, because you had 3 rolls left and got exactly 100. Nicely done. All right, so you guys see some different ways that you were able to fill these in? Uh-huh. So a couple of things happened here. There were a couple of people that got exactly 100, and there were people that got it on the last roll, which was pretty remarkable that they got exactly the numbers they needed on the last roll. There were some people that got very, very close, but ran out of rolls. And then there are people that got exactly 100 and had rolls left. So it all came out a bunch of different ways. So just on how you could fill in that grid and how you approached it. Now, you obviously did it the quickest way, probably because of the numbers you got. Was there a way that you filled it in, or did you just randomly put them anywhere? Did you start at the top and go to the bottom, or did you work outside in, or how did you do it? You just filled them in, random ones as you went along? All right, now you came along next. Do you remember how you filled yours in? You just went a zigzag all the way from top to bottom, however, so instead of doing a rectangle, you just went by ones?
I kind of went in a rectangle, but then I just filled it in.
All right, so you did a rectangle and then filled them in that way and it went along? All right, there you go. First activity right there, nicely done by the 6th, 7th, and 8th graders at Piute Mountain School. And once again, a big thanks to all of the staff and students at Piute Mountain Elementary School. We had a wonderful time out there, and hope they are now doing better with their water issue that they had out there. They had a little bit of a problem, so hopefully between now and then, everything got settled out there. 636-4357 is the phone number. We do have phone tutors available on Tuesdays and Wednesdays, most of the school year until 5:30 in the afternoon. Don't forget, San Luis Obispo County, that phone number is toll-free. Phone numbers are at the bottom of your screen periodically throughout the program. Right now, we're going to go back to the phones. And Ruby, how are you this afternoon?
I'm good. How are you?
I'm wonderful. And as soon as you're ready, let's go ahead and see what math problem you're working on.
Let's go for it, Ruby. What you got?
Okay. So it's 6x plus 3.
6x plus 3.
X plus 7.
Plus
Are there
x.
parentheses anywhere?
Yeah, parentheses around the x plus 7.
Okay. Parentheses x plus 7 next to the 3. Okay?
Mm-hmm.
Continue.
So then that would equal negative 15.
Equals negative 15. Okay. So there's a lot to work with here. We have negatives. We've got a coefficient next to parentheses. How would you like to start us off here, Ruby?
I would like to start by bringing down the 6x.
So let's take care of, you said the 6x. Okay, so how would you like to bring down that 6x?
Just bring it down.
Just bring it down. So like put it out of the way so we can work with everything else?
I guess you could say that.
Okay, I think I will. So I'm going to go ahead and just move this 6x off to the side. We'll just kind of remember that it's there so we can work with the rest. We're not getting rid of it. We're just going to bring it back a little bit later. So this 6x comes right over here. All right, so we have our 3x plus 7 equals negative 15. All right, what do you want to try with this?
I want to do the 3 times that.
So let's go ahead and distribute that 3 into the parentheses. We have 3 times x, which will equal what?
Positive 3x.
So we have 3x, and again, we're keeping that positive sign over, okay?
And then do 3 times 7.
Let's distribute that 3 to the 7. So what does that get us?
Positive 21.
Okay. Hey, is it time to bring that 6x back here yet?
You could say yes.
Let's go. Come on over, pal. All right. So we have 6x plus 3x plus 21 equaling negative 15. Ruby, what would you like to do next with us?
I would like to take away the 21.
Let's get 21 out of here. Now, this is going to pose a little bit of a challenge because, as you remember with Caitlin earlier, whatever you do to one side, we've got to do to the other side. So we can take 21 away from the left side of the equation, but we've also got to subtract 21 from the right side. Do you want to kind of keep that over there and come back to it in a bit, or do you want to do that now?
I would like to do it now.
Let's go ahead. So how would you do negative 15 minus 21?
You would add them because they're both negative.
Oh, okay. So because we're dealing with kind of the negative zone, we can add their absolute values together and know that they'll remain negative. So let's do that. We have 15 and 21. What is their sum?
Negative 36.
So we end up with negative 36. Okay. So we have negative 36 on the right side of that equation. Now we're left with 6x plus 3x on this side. What can we do with that?
We could add them together.
Let's add them together. So 6x plus 3x equals?
9x.
Now we have 9x equals negative 36, and we want to isolate that variable. We want to get that x by itself, so how do we do that?
We would divide 9 by both sides.
Let's divide both sides of this equation by 9. We get x by itself, and we're left with, on the right side of that equation, negative 36 divided by 9. What does that get us, Ruby?
Negative 4.
X equals negative 4. Now, you can take that and pop it back into the initial equation and see if it fits. But television is a very finite field as far as time is considered, so we can assure you it certainly does, Ruby. Nicely done. Thank you very much. Great job.
Great problem right there. Congratulations, Ruby. Your name is also entered into a drawing for 2 tickets to any CSB athletics event this year, so congratulations on that. 636-4357 is the phone number. Phone tutors are available until 5:30. We have our very special guest, Emily, in studio with us. We're going to get Emily to work in just a little bit, but first we're going to go back out again and visit with Marylou.
Today we are at the Public Works Traffic Division, and I am again here with Ed Murphy, Civil Engineer 3.
Whoa.
And we were talking about, we are in the control center, and we could see all the traffic lights that are going on and intersections that have cameras, and see all that. From that, you can kind of take information about determining things that's going on in the street.
Yes,
right?
such as the speed of cars that are driving on. They're getting a typical speed profile of the cars that are driving on a typical roadway. And I could show you how we do that right over here. First off, we have these. Probably seen them out on the side of the road, or this hose going across the road, connected to this. We use it for counting cars, but we also use it for determining speed, which I'll show you here in a minute. And these are laid out. They take air pressure in the end, and every time a car drives over it, sends the information into this box, and then we download it into the computer when we bring it back here in the office.
See, whenever I drive over those, I'm thinking, oh, I'm going to be in trouble here.
No, you're not in trouble. We're just trying to gather data to get an idea of what's going on out there so we could help better serve you and every other driver and pedestrian and bicycle rider out there in the city. So here's a little stick figure sketch of 2 intersections in the roadway between them. And here's the little box that we would lay. We'd chain it to a tree or a sign or something like that. Please don't steal our boxes or our hoses. And lay the hoses out across the roadway at, we're typically 10 feet apart. Now, where does the math come in? We're trying to figure out the speed. We know the distance between the two hoses, and as the car drives over it, it hits the first hose and then hits the second hose, and there's an amount of time difference between it. We know the difference of the distance over the distance of time, and the change in distance over time is the speed. And that's what we get. So let's say we have 3 cars that drive over this, and the first car drives over it, and by the time it hits the first wire, the second one, the time was 0.273 seconds. That seems pretty fast, and it is. It's almost like swimming in the Olympics. It goes down to that, because if the cars are driving like 30 miles an hour or 50 miles an hour, it's, boom, boom. You feel it as you go over the hoses. So we know the distance between them is 10 feet, and the time it takes to go through it is 0.273 seconds, crunches out to 36.67 feet per second. But in units that we use in traffic engineering is miles per hour, at least in the United States. That's how we typically do speed. So we want to convert that from feet per second into miles per hour. So for the distance, 1 mile is 5280 feet. And then there's 3,600 seconds in 1 hour. We multiply that through, the feet cancel out, the seconds cancel out, we end up with miles per hour, and we get 24.78, which is about 25 miles per hour. Same thing with the car number 2. We, let's say they drove over it at 0.170 seconds. That crunches through into 40 miles per hour. And whatever the time is between the two hoses, that's how we determine the speed. And then we can add those up, all the speeds up, and divide it by, to get the mean or the average speed, add all the speeds up, and then divide it by the number of cars in our sample. For this case, we only have 3 cars. We add all 3 of the speeds up, divide by 3. The average speed is 40 miles per hour.
So you know that maybe that an average speed to set for that street would be possibly 40 miles per hour.
Yeah, we use a different, for setting the speed limit, we use a formula similar to the mean. It's called the 85th percentile. It's a little more complicated. I don't think we have the time to get into it now. But that would be 85% of the vehicles surveyed are traveling at that set speed or less.
And you kind of have something.
Sure. In this case, we don't put the hoses out when we do this today. We use a radar gun. And unlike police out there trying to give you a ticket, we're not trying to do that. I'm just trying to get, like I said, we hide in the bushes so you don't even know we're doing it. And we take a sample. In this case, we took 105 cars, typically 100 because it keeps it an even number, but let's complicate things right now, right? So 85% of those cars is about, what did we say? 81, it was like, it's about 89 or something like that. Sorry. Yeah, 89 cars. So here we see, as we add them up from the bottom up, like I said, it's 85% or lower. 1 car was going 40 miles an hour. We got 2 cars going 42 miles an hour. We keep adding them up, and somewhere 89 is somewhere between here, between 54 and 52. So the 85th percentile speed is about 53 miles per hour. To set the speed limit, we always round up, and that would make the speed limit. This is the computerized program that does all the crunching through, does a few more extra calculations, and we set the speed limit at 55 miles per hour.
Now, like you said, it's not you guys who are really setting it, it's the public, right?
The drivers, yeah. Like I said, we want somebody, we take like the first car of a platoon or just with the comfortable speed of them driving on the roadway. And of course, laws come into play. Near a school zone, it's 25 miles per hour. In a residential area, maximum speed is 25 miles per hour. There's in maximum speed in California, I think on freeways is 60. There's other set laws that we have to observe, but local roadways, arterials, collectors, could be anywhere from 25 miles per hour to 55 typically on the faster arterials. Yeah.
Now, what schooling did you need for this profession?
I am a civil engineer. I got my bachelor's degree in civil engineering, and that was years ago. Lots of math. I'd also like to say, in addition to math, also just writing skills and social sciences. I mean, you need to know the technical part right here, but then you also need to communicate it to your boss and to other people in the public and relate to others. So, a lot of technical writing classes and things, don't neglect those, but certainly paying attention, a lot of attention to the math. And your efforts are not in vain. You are spending quality time working these problems. Because later in life, when I took physics, I remember in college, it was, then I really saw how the math made the physics so much easier. And it really made sense, and it really came to life. And it really, yeah, it was really exciting.
It's cross-curricular is what it is.
It is. But it was a tool, it was a language that helped explain what was going on. And nowadays, I look up a lot of things in a book, a formula in a book, but I have that background training, and my mind's been trained on how to think critically, to think mathematically, and apply that to what we're doing here today. So it may seem a lot of simple math we've done, but I put in the time, trust me.
There's a lot.
But very enjoyable, a lot of fun. Anyone can do it if you work hard enough. It took me a while. I'm not the smartest guy in the book, but absolutely. And it's a lot of fun. This has been a good choice of vocation.
Thank you again, Ed, for letting us come today to
You are welcome.
visit the Public Works Traffic Division. And all the new technology and everything going on here has been absolutely amazing. And being able to see all the cars and the intersections and how your maps work with all of your signals. Truly amazing. And here's a little something
thank you.
to thank thank you for letting us visit today. And so we are going to head back to the studio.
All right, thanks to that, Marylou, and also thanks to the Public Works Traffic Division for helping us out with a little bit of math and how the traffic flows and how they determine all of that and the speed and things of that sort. 636-4357 is the phone number. We have Emily in studio with us, and for coming in today and doing some excellent work, we are going to award her her very own Cubby's Pizza. Have you ever had pizza?
Yeah.
You've had pizza sometime in your life already?
Yeah.
I eat pizza all the time. I love it. Do you have a favorite topping, or do you just like it plain?
I usually just like pepperoni.
You like pepperoni? That's good stuff. You ever have that twice baked pepperoni? You know what that is?
No.
That's pretty good. That's extra crunchy and stuff like that. That's
Yeah.
some good stuff right there.
Crispy.
Old man, I'll eat up all that pizza pie right there. Anyway, you're going to go to Cubby's. Have you ever been to Cubby's?
Yeah.
Oh, so good. Hopefully you like Cubby's?
Mhm.
All right, good. They have that Chicago deep dish. Have you had that, or do you get the regular pizza?
I just usually get the regular pizza.
All right, well, you know what? You can get yourself a regular pizza, or who knows, you might try the deep dish one time. All right? But since we gave you that, I need you to do some more work now. You ready?
Okay.
All right, head on over to the board. We're going to take a look at another problem that's in your book. This is math on the spot in your book. It says, the sum of a 3-digit number and a 1-digit number is 217. So first of all, Emily, what does it mean when they say sum?
Sum will usually mean the answer to a addition problem.
Right, you're going to add the numbers up. The product of the numbers is 642. So if they're looking for the product, what operation will you be doing? Add, subtract, multiply, or divide if they're looking for the product. Have you heard that one before?
I have multiplication.
There you go, multiplication. And let's take a look at the end of it. If one number is between 200 and 225, what are the numbers? So you and Devin are going to go ahead and work on this and see if you can figure out what the number is. Okay?
So what do we need to find in this problem to be successful? We need the 3-digit number and the 1-digit number. Now we have some information that they gave us, and we went ahead and laid it out here on the board as kind of a visual to help make sense of this. And the nice thing is that you can use any other information you have that's here to help you out with that. What would you start off with? What piece of information that you have is going to be the most useful to begin with?
The fact that it's an addition problem, so you know that this will be a sum, not a product.
Okay.
And that for this answer, 2 of the numbers have to be 210.
So we know, at the very least, something about this 3-digit number, right? What do we know?
The 100 in the 100 place is a 2.
Let's go ahead and throw that in there then, right? And we kind of had that information as well down here in this comparison part, because we knew that the answer had to be between 200 and 225. So we know, at the very least, that there's a 2 in the hundreds place, right? Now, the fact that the sum here is 217 also gives us some information about what this can't be, right? What do we know this can't be?
It can't be 217.
What would this 1-digit number have to be in order for this to equal 217?
It would either have to be a
Well, let me put it to you this way. If this was 217, right? What would this have to be in order for this to equal 217?
It would have to be a 0 because
Right.
it would be
Now, I'm going to use that information to kind of go back here. If this equals 0, what does this have to equal?
642.
Well, if we multiply it by 0, what would this be?
0.
0. So we know that this can't be 0, right? So which means it can't be 217, right? Could it be less than 217?
It could.
Okay. What could it be?
It could be 216.
So in order for this to be 216, what would this have to be?
It would have to be a 1.
Sure. Now, if we multiply these together, is that going to equal 642?
No.
Okay, so we know it's not 216. We know it's not 217, and we know it's not anything greater than that. So let's keep working backwards and see if we can use some good old-fashioned trial and error to get closer. If it's not 216, what's the next number we could try?
215.
Let's try it, because if this equals 215, then what does this one-digit number have to be in order to equal 217?
2.
2. Now, if we multiply 215 by 2, is that going to get us 642?
No.
We could try. No, right? And what tells you no without even doing it?
Because 200 plus 200 would be 400.
So you're estimating that it's going to be around 400, and so that's not even close. Estimation is a good skill to multiply before you multiply, so you don't have to do all that work. Great, so we know it can't be 215. Let's go one more down. Let's try the next one, which would be?
214.
Let's try 214. Now, if this is 214, what does our one-digit number have to be?
3.
Now, if we multiply 214 by 3, do we get 642? Well, maybe we can try the area model really quickly to calculate that out. So we have 3 times
I'll give you
200.
a moment
Four-
to conclude that.
200 times 3 equals
600.
3 times 10,
30.
and 3 times 4.
12.
These equal 42, 600, 42, 214, and 3. We did it. Nicely done. Oh, phenomenal. Great job, Emily.
All right, Emily, come on over here. And that problem was an excellent problem for you to work on. I like the way you guys reasoned through that one right there. And what you were doing is taking a look at that and going, all right, you know what? 200 times the 2, you were saying that's 400, right? Without even having to work out the whole problem. And that's the key, is to look at patterns and know some of the little things behind it. 200 times 3, 600, so you know you're probably going to be close, if not right on it. And if you tried 200 times 4, what would that be?
It would be 8.
And you know that would be too high, right? So that way you know, let's try the 3 and see if that works. So nicely done. Excellent work all day today. And because you have done some great work today, we are now going to award you with a brand new uniform. Have you ever had a uniform?
No.
No? Well, you have a uniform now. And this is your brand new uniform. You are now an ambassador for Do the Math. Do you know what that means?
Not really.
Okay, you have to let everybody in the world know about Do the Math. Can you do that?
Yeah.
Well, you can try it with a couple of people first, right? All right, nicely done. Did you have a good time today?
Yeah.
All right, you know the difference between the positive and negative thing a little bit better now?
Yeah.
Good, that's what we want to do. Hey, you know what? We do have phone tutors available until 5:30 this afternoon. Don't forget, San Luis Obispo County, those 2 schools still battling. Keep it going. Until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, California Resources Corporation, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, Bakersfield City School District, and the Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.